Happy Friday. Your tests are in the grade book, so you can check those out. We'll be getting those back to you on Monday. Today we are going to start the new unit, and I need you to first make sure that you all have a note packet. So if they haven't been passed out yet, pause this video and please go get them passed out. If they're all passed out, or once they are, please turn to page 3 in your note packet. We are actually going to do the second section before we do the first because it's kind of the easiest one for me to talk you through. And a lot of it is kind of familiar to what we just got done doing. So this entire unit is on functions, and really all functions is that they are equations. They're just written in a different form. And basically last unit, that's all we covered were equations. So what function notation is, it is another way to represent an equation. We will be using functions as inputs. We'll be taking numbers and inputting them or plugging them in. So functions are used to plug numbers into equations. So equations, like anytime there's an equal sign, it's considered an equation. But we are going to write them in function notation because it's going to help us to plug numbers in. It's not any different. That's kind of the nice part. Like for example, if you had y equals 2x plus 1, this is called a linear equation. But the minute I take the y away and I change it to f of x or g of x or h of x or whatever, and then you just rewrite the right side, this now becomes a linear function. So this x and this x, they're the same number. So basically it's saying take this x value and plug it into the function f. So how you read this, so if you have f parentheses x, this is read as f of x. And this right here, whatever number is in here, this x is the number that you are plugging or substituting in. So that's what we're going to start out with. And if you didn't grab a calculator when you walked in, again, pause this video, go grab yourself a calculator. You're going to need it because I'm going to show you how basically the calculator can do all of this stuff for you. So first thing we're going to do is just write these equations as function rules. And this should be pretty easy. So it says write the equation y equals 5x plus 1 using function notation. Basically, take the y away and change it to an f of x, and then just rewrite the rest of it. That's it. That's function notation. I wish I could see your faces right now because you're probably like, that's it? This is too easy. It gets a little more difficult when we have to plug numbers in. But so what we use function notation for, though, is like what it's asking you to do down here in B. So it says, what is the value of g of x equals 5x plus 1 when x equals 3? So basically what this is saying is what does this function or equation give you when you plug a 3 in for x? So how we write this, we're taking a 3 and we're plugging it in both spots. So we're going to do g of 3 equals 5 times 3 plus 1. And this is where your calculator is going to be your BFF. This is not something that's like difficult for you to do even in your head, but they will possibly get a little more difficult, so I want to show you. So you would just do 5 parentheses 3 parentheses plus 1, 16. So to write this, you would say that g of 3, so if I take a 3 and I plug it into my function, I get a 16. That's it. I'm sure some of you are looking around like, this has got to get more difficult, and it really doesn't. All right, let's flip the page to page 4. and take a look at a couple of these examples, these try-its. Since I'm not there, we're going to do these together. So the try-it says evaluate each function for x equals 4. So I'm going to take a 4 and I'm going to plug it in here. So g of 4 equals negative 2 times 4 minus 3. So negative 2 times 4 minus 3 gives me a negative 11. So g of 4 equals negative 11. If I take a 4 and input it into my function, the output is a negative 11. And then this one, if I plug a 4 in, I do h of 4 equals 7 times 4 plus 15. So h of 4 equals 7, 4 plus 15. You get a 43. So like how this may possibly look a little bit more difficult, like what if I gave you f of x equals 3 plus x over 2. And I wanted you to find f of, or plug 4 into that. So f of 4 then would equal, now I'm just going to take the 4 and plug it in right there. So I'm going to do 3 plus 4 over 2. So then if I'm going to plug that in all at once in my calculator, use these calculators to your advantage, you guys. So 3 plus 4 divided by 2. And you get a 5. So f of 4 equals 5. So that's the first part of today, plugging numbers in, making sure you understand how to plug them in appropriately and into your calculators. But that's actually, honestly, this is the only new thing for today. The rest of what we're going to do is all review from like last unit and from your test that you took yesterday. So example 2 wants you to write a linear function rule of this equation here. So number of bracelets is like your x's, cost is like your y's. So anytime they give you a table, whatever comes first are your x's and whatever comes second is your y's. So to write a linear function rule, just like kind of the warm-up that I did yesterday right before you took your test, you need to write an equation, and we're going to write all of our equations in point slope form given a table. So in order to write an equation in point slope form, you need a point and you need the slope, which all can be found using this table. So the point is always going to be the first numbers here. So 1, 17. So that's your x1, y1. Now to find the slope. Slope, you have to figure out how does y change over how does x change. So to go from 17 to 32, you add 15. So 15 over. To go from 1 to 2, you add 1. 15 over 1 is 15. So then my point slope form is y minus y1 equals m x minus x1. And that's it. We're not going to actually convert these over to functions. We're just going to leave these in point slope form. You guys would be able to distribute, get these into slope intercept. Once it's in slope intercept form, then we would convert it to function form, but we're not going to worry about that. So then for the try-its down here, you do the same exact thing. So again, you need a point and you need a slope. So my point is always going to be the first point, so 1, 6.5. That's my x1, y1. Then you have to figure out your slope. So how does y change? So to go from 6.5 to 13, I go up 6.5. So 6.5 over, and to go from 1 to 2, you go up 1. But remember, you can't have decimals, so let's see what the calculator tells us here. So if I take 6.5 divided by 1, and then math, enter, my slope is 13 over 2. So there's my point, there's my slope. You plug into your point slope form, which is still up on the board, and you do y minus 6.5 equals m parentheses x minus x1. We'll look at one more together. That way I feel a little bit better about coming back on Monday. So again, I'm going to find a point, find the slope. Point, you're always going to use the first point they give you, so I'm going to use 1, 1. That's my x1, y1. And then for slope, to go from 1 to 4, I go up 3. To go from 1 to 2, I go up 1. 3 divided by 1 is 3. So then my point slope form is y minus 1 equals 3, x minus 1. And that's my point slope form. So again, that's nothing new. So let's flip the page and you're going to be hopefully happy once you see what's even on this page. So page 5, graphing. So when you graph functions, there's a couple of different ways you can graph functions. We could create a table of values and just plot points, or you guys should be able to look at these and know how to graph them. So this is in slope-intercept form. So when you are graphing in slope-intercept form, just as a reminder, you first plot the y-intercept. After you plot your y-intercept, then you use your slope to do rise over run to find the second point. So that's what we're going to do for each one of these graphs. So the first function, I have a slope of -1 and a y-intercept of 1. Now slope, remember, you're going to want to write that as a fraction. So if you have a -1, it's like a -1 over 1. So I start out by plotting the y-intercept. So I go up to 1 on the y-axis and I put a dot. My slope is -1, so that means from here I go down 1, right 1. And you can do that as many times as you want. You only really need to do it once. And then you play connect the dots. Maybe, there we go. Done. And my slope was negative, the graph's going down, so that's another way to kind of check yourself. And then for this one right here, I have a slope of 3, which is 3 over 1, and then a y-intercept of 1. So I go up to 1, put a dot, and then from here I go up 3, right 1, and then connect the dots. All right, so today you guys have a worksheet that will be passed out to you. Problems 1 through 8 are all just you plugging numbers in. So for number 1, you actually are going to take a 2 and plug it in and a 6 and plug it in. So like for number 1, you're going to end up having an f of 2 and an f of 6. Same thing for number 2. You're going to have an f of 2 and an f of 6. So 2 answers, 2 answers. 3 through 8, you're just going to plug a 5 in. If I were you guys, I would simply just plug the 5 in and plug it all into my calculator at once. 9, 10, and 11 are tables, so just take a look at the table example that we just did. And then 12 and 13 are just graphs. When you are done with this, I do want you to turn this in today. You should have no problem getting this done if you are working. So I do want this turned in today. Monday, we will be going over what actually makes something a function. Like we're obviously kind of going a little backwards because we're dealing with functions already. But if you plan on being out at all next week, please make sure you are logging in to Google Classroom. I've got some pretty awesome videos that I created last year to help out with that. But good luck on this, and I will see you all on Monday.